Welcome to Morpheus Chair, the program where you learn to build robots from your comfy chairs. So thanks a lot for the comments on the previous video. They helped a lot to define this the videos that we're going to produce now. So this video is about MoveIt. This is the first step to MoveIt. So we are going to basically create the package for any kind of robot that you can think of, the basics. And in the next videos, we're going to go deeper in some elements, basically in all the elements that we need to do the perfect MoveIt package. And that's it. To the workbench. Hi, and welcome to this third episode. So, like always, we are going to first launch our RosJect, or you open your local setup. Remember that all the code that we are going to do today will be uploaded here eventually. So bear in mind that. You can close this already. And let's start. So the first thing we have to do for MoveIt is have a URDF file of our robot. I won't go into details in this episode. We've done loads of tutorials about that. If you want a tutorial on how to create a URDF for a robot arm, please leave it in the comments below. But we're going to have a look at the URDF that we're going to use for MoveIt, okay? And that way you'll have some idea. So I've done a notebook with the instructions. They are not exactly what I'm going to do here, but it's to have the basics of what to do. So the first thing is we're going to have a look at Open Manipulator Support Description, which is the package that contains our URDF, in this case in form of Chakra, which is a URDF macro system. So we're going to use this Open Manipulator Support URDF, which essentially is we connect to the world. This is really important, the base link, and the base link will connect everything else. This is really important for something that I'm going to explain in a moment related to virtual joints in MoveIt. So if you don't have a robot model, a URDF that it's connected to world, you have two options: or you connect it to world through a link, or you do a virtual joint in MoveIt that we'll see in a minute how to do it. Essentially is a serial chain of links, folder links of the arm, and this has some really strange things that you might need. I'm going to explain it, but it's not something that you may have to do in your robot. It depends on the structure of the robot. In this case, it was needed. So in this case, there's some joints that mimic other joints. So in this case, joint 7 mimics joint 8 mimics joint 7, and at the same time, joint 9 mimics joint 8. So essentially what the joint 7 does, the joint 8 and 9, which are the grippers, will do it. Yeah, that's because how the gripper works in this Open Manipulator robot. Yeah? Okay, so this is the URDF, very, very fast. So let's have a look. What do we have to do to generate our MoveIt package? So it's really, really simple. You just have to at least launch it. Then configure it's a bit more challenging. So we go here and we execute MoveIt setup assistant, launch. And then in your local computer, a window will appear. In ROS Development Studio, you need to just click graphical tools, and a window like this will pop up, and we have our MoveIt assistant. So let's have a look. I'm going to create one from 0, okay? with you guys. So let's start. So create new MoveIt or edit. Edit is when you have something already. Yeah, so if I go here and I edit and I go the one that I've already done, I click the folder and then I load files, then it will load everything that I've done and all the setup that I've done, okay? This is in case you want to change something, in case you want to add some sensors and this kind of stuff. That will use it for sure. But for us in this case, we are going to close it and launch it again. And we're going to do a new one so that you know exactly what to do. Let's do it a bit bigger and then create new MoveIt. The first thing is you need a URDF or a chakra. So in this case, we go to where we had these chakras, which are here. In this case, you would go to the package that you've defined the URDF or the chakra. In this case, support. Okay, done. Then load files. And there you go. You just zoom and move it. This is the first thing you have to check, that the URDF is correct of what you expect it to be. As you can see, is a correct model of our open manipulator. Okay. Then the first thing is to calculate the auto collisions, the self collisions. This is to avoid making MoveIt work without needing it to. For example, if we do this, we won't check the self collisions with some elements that it's impossible that they collide, or we know they are colliding all the time. So there's no point on calculating those collisions, and this will make it much faster. To do this, you have this slider and you can select if you want to test 10,000 random positions until 100,000. The more the better. The only problem is that 100,000 will take more time than 10,000. Because I've tested it, the results are exactly the same with 10,000 or with 100,000. But this won't be the same with very complex robots. So humanoid robots with fingers and this kind of stuff. The more joints that you have, the higher this number has to be, because you have to test more positions. Okay, so what it does is basically test random positions and see if it collides. Okay, so let's go. There you go. This, I don't find it very useful. So I really like this matrix view. Okay, so we can see here, if you hover over it, you see that green means never collision and blue means adjacent links. These are all the collisions, the pair of collisions that won't be calculated. The ones that will be calculated are, for example, base link with link 3, because I don't know if it can collide. Because we've generated this, we know that it can collide. So we have to calculate it. Yeah, it's essentially that. Okay, once we have it, and this is very important because otherwise when you move forwards, if you haven't calculated this, then it will say that it collides with everything. Virtual joints. In our case, the virtual joints, it's with the world. So we could calculate, we could do it, but in this case, we're not going to put it because it's connected with the world, as far as I know. So let's do that. If it gives some error, then we'll add like a dummy one. So this is the key to MoveIt, because we group it in kinematic chains. By grouping, you don't have to calculate all the inverse kinematics of all the robot, just of the groups. When you calculate one group, for example, the arm, that we're going to do it right now, open manipulator arm, it won't calculate other groups like the gripper, for example, if we do the gripper. Yeah? It supposes that the gripper is static, it won't move, it's fixed. Yeah? So now we state the kinematic solver. There are many kinematic solvers. We're going to use the standard, and then in next videos we probably will work on more complex ones that are faster and more precise, and you can customize them. Yeah. Okay, this we leave it by default, it's okay like that, and for the moment we don't put the group default planner. Okay, and then to get the components, we can do it by joints, by kinematic chains, by links, or add subgroups if we have previous groups. Yeah, so let's add by joints. In this case, we're going to add the world until number 6, which is, yeah, that. So the only thing that we don't add is this one, which is the one that when it rotates, it moves this joint and this joint because they mimic. Yeah, so these. And we put it there, and there we have it. Okay, if we wanted to do the gripper, for example, we would put here gripper. Then in this case, the kinematic solvers, the default one, doesn't work with chains that aren't serial chains. And in this case, this is not a serial chain because the two fingers, let's say, are connected to the same link. So it will give problems. So we would leave it like this for the moment, and then we would add, for example, by links. So we would add link 7, link 10, and link 11, for example. There you go. Yeah. Okay. Save. And there we have it. Then we have the open manipulator arm and the gripper. Okay. Then we're going to go to robot poses, which is the fun part, which is add a pose. And then we're going to generate some poses. For example, let's add 0, for example, arm 0, like that. And then another pose that would be, for example, arm home, which I'll put this, I think, around 7, this around minus 2.3. Let me have a look here. There we go. Then I think I have to put, yeah, more or less like that. And that's it. Yeah, great. But we could move, for example, this one and put it like that. I don't know, like 1.57. There you go. Okay, and now we could do other pose for other groups, like for example, the gripper, which in this case, because it mimics, then we can move this and say, hey, let's put this, I don't know, like this is open, gripper open. Yep, save. And there you have it. We have gripper. Yep. But as you can see, there are some issues here. That's because this is quite complex. So for the moment, we are going only to work with the gripper. Yeah. In the next videos, we'll probably work deeper in this. Okay, so we can delete it. There you go. And we're going also to delete the gripper for the moment. Okay, so now robot poses, we have home and 0. Home and 0. Yeah, we can do another one just for fun. Arm, I don't know, pose 1, and then we're going to lower like this, like, for example, like that, then like that, then we turn, and we turn that like that, and we put this there. Okay, there you go. So now we have 3 nice poses: 0, home, and pose 1. Great. End effectors. In this case, we're not going to put any end effectors for the moment. As I told you, we'll do it in the next videos probably. Then passive joints. This is only for robot arms that have passive joints, or robots that have, for example, caster wheels and this kind of stuff. In this case, nothing is passive here. Then we have the 3D perception. For the moment, we don't have any cameras, nothing. Probably we'll add some point cloud and in the next videos, depending on what you people ask for. Then simulation. It can generate the URDF, which is not necessary because the chakra it's already useful for simulations for Gazebo, but it can do it. ROS control, we can select add it like here by hand, or we can add it automatically. There you go. So we have follow joint trajectory, and we have this already set up. Fantastic. Then we go here and we say great, and now we can generate it. So we go here, we create our, for example, I don't know, open manipulator episode 3, MoveIt config. Normally the ending is always MoveIt config for the other people to know. Oh, sorry. So this would be the name of this folder. So rename, there you go. And now I select this folder. And then it will take that as the name of the package. Yeah, like I said, it doesn't matter. Okay, generate package. Now it says, hey, be careful because you don't have any end effectors and you don't have any virtual joints. They are not necessary, but they say that you haven't done it. So we know that we don't need it. As far as maybe we need the virtual joints. So let's have a look. There you go. So now we can exit. And now we go to, I have it around here. There you go. So copy. We go here. Rip. Open manipulator. Episode 2. And then Rviz tutorial. Sorry, I just missed. Oh, okay. I left that. There you go. Whoops, sorry. There you go. Okay, launching. Have a look that if there's any error or something that Okay, let's have a look. What do we have here? We resize, and there you have it. So we have our robot in MoveIt with a very basic package, which we'll upgrade in the next videos. But now we can go to planning. We can go here and say, hey, let's plan from the current state to some state that we have, for example, pose number 1, update. Then you see that the orange is there and puts like that. Then we hit plan. It's planning, 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 planning. Great. And then we can execute or plan and execute. Execute. Now we see that the current position is that one. There you go. So now if we want to move to another one, then it would be, okay, current, we update, then go, let's put home, for example, update. You see that now the orange is the desired position. Now we plan, and it plans from the current position to that one. And now we hit execute. And now it executes, and that is what the real robot would do. Yeah, it depends on the kinematic solver, the planner, a lot of things that we'll touch in the next videos. But essentially, we have a MoveIt package for our robot arm. The process will be exactly the same for your robot arm, just that it will have different links, different joints, but the basics are exactly the same. And yeah, that's quite it. And that's all for today. Thanks a lot. Give us a like if you liked the video, and subscribe if you haven't done it yet. And in the next video, what we're going to do is possibly go a bit deeper into the MoveIt. It depends on the comments below also, or what you want to go deeper first in the planner, or maybe in the kinematic solver, or maybe the gripper issues and so on, how to control that, or go to the simulation. You decide. Until then, keep building.